Hello everyone. Today we are going to talk about assembly language. So I think most of you know how a high level language program is converted into machine level language. So we have high level language program, maybe it is written in C, C++ or whatever. So this goes as input to a program called compiler. Okay, and this compiler produces assembly language program. Assembly language program may not so all the compilers may not generate the assembly language program, but some of the compilers generate assembly language program, and this goes as input to another program called assembler. Assembler, and finally this assembler converts assembly language program into machine language. Machine language, which is zeros and ones. Ones and zeros. Okay. So if you can see here, assembly language is a low-level programming language which is designed for a specific type of processor. So if you look at 8051 microcontroller, the assembly language instructions will be different from the assembly language instructions which belongs to 8253 microcontroller. Okay, the instructions might be similar, but the actual formatting and all those details will be different for both the microcontrollers. And you can see here, this assembly language is produced by compiling source code from a high-level language program such as C or C++, just like I have shown you here. Okay, and this assembly code is converted to machine code by the program called assembler. Okay, so it's software which converts assembly language program to machine language program or code. So I also told you this. Some of the compilers might not generate assembly code. They will convert the high-level language program directly to machine language. So why should we use assembly languages for performance reasons? Okay. So this assembly language is tightly coupled to the underlying hardware. So if you want to use the hardware efficiently, we have to use assembly language instead of the high level language, right? Okay. So these languages differ from different processor architectures. Just like I told you, the instructions are different for 8051 and 8253, but they look similar. Uh, so writing these assembly language programs is hard or tedious, or takes more amount of time because the instructions are not easy, like just like a high level language program. It is little bit difficult. So you can have a glimpse of why it is difficult by looking at this example. So this program, it is for adding two numbers. So just for adding two numbers, I have this much size of program. But if you look at the Python program for this, it is typically 3 lines. Okay, so let's see what is happening in this program. So for input and output, we will be using a specific register called register F. So first of all, for adding two numbers, we need to read those two values. So here we are reading the value from keyboard and storing into the register F. And then from register F, we are moving that value to number 1. Let's say this is a variable that we use in program. And similarly, we are reading the second value from keyboard again into register F, and again from register F we are moving that value to number 2. So we have both the values now, and then we are again moving those values to register 0 and the second value to register 1. So why we are moving all these values to registers is typically microcontroller supports operations only on registers. Okay, most of the microcontrollers. But some of the microcontrollers also allow us to perform operations on memory. So, but in this program, let's say this microcontroller is only supporting operations on register. And then finally, we have value 1 in register 0 and value 2 in register 1. We are adding them and storing the result in register 2. So we are adding register 0, register 1 and storing in register 2. Again, this register 2 value is moved to a variable called result, and from result it is finally moved to the register F, which we are printing onto the monitor. Okay, and after the task is over, we write the halt instruction to tell the microcontroller to stop the execution of program. So this is how assembly language code looks like. So high level language programs are much easier when compared to assembly language programs. Okay, and generally we use assembly language programs for getting better performance when compared to high level language programs. So that's it about assembly language. Thank you.